Dear students, welcome to another lecture in industrial engineering. We were discussing about process planning, and today we are in this lecture we are going to see these two topics: deciding sequence of operations as part of the process planning and operation sheet. Now the first topic is deciding the sequence of operations. Now you consider yourself to be a process engineer. You see, if you're a process engineer, you should have the knowledge of all types of manufacturing operations. What all in the shop floor, what operations they do, and about all machines and everything, you should have knowledge. Certain operations, by their nature, should be performed ahead of others. When we are saying sequence of operations, means you see what should come first, what should come next, and what should come thereafter. You see, this is the order of these operations we have to decide as a process engineer. Okay, process planning consists of uh, you see, this is what we are seeing. Process planning, as part of process planning, sequence of operations we're seeing. So process planning is selection of materials for the job that you are doing, selection of machines on which you are going to machine the product, what are the processes that will be performed on the workpiece, and what are the equipments that you are going to use to add desired features in the workpiece, so that the final product is made or machined or fabricated or produced at an economic cost. So the process planning is consisting of all these things. Okay, now here they say the figure shows the sequence of operations as explained below. Now where is that figure? Let me see, show you the figure. Yeah, in this slide it is there. See, this is a figure which is showing the sequence of operations. Now on the top you can see there are certain basic operations. Under the basic operations, no, things like forging, casting come. Okay, then after that is the principal operations. You see, we'll be dealing in detail with each and every type of these operations. The second is principal operations. In the principal operations, some examples are extrusion, rolling, drawing operations, etc. And then there are major operations. Major operations can be turning, shaping, milling, etc. Then the auxiliary operations like heat treatment, welding, and like shot peening and other things. And finally, there are certain operations which are called supporting operations, like inspection at various stages, the quality control, and other things. So these are the five different operations. First, basic operations we will do, then later principal operations, then major operations, auxiliary operations, and supporting operations. Now what is basic operation, what is principal, and other things? Now let us see one by one. Okay, now first come to the basic operations or basic processes. Okay, the first step in deciding the manufacturing sequence of any part is selecting the basic process. Now basic process, the definition is given here. It is the process from which the raw material is obtained. This basic process is first decided from the application of the final product. The basic operations examples are given. Forging is one basic operation, casting is another basic operation, and etc. That means there can be some more also. Okay, see, once this forging is done, what according to this definition, what we are getting is the raw material that is used for our for the principal operations. Okay, so this is the basic, the first step, basic process. Okay, second one is principal process or principal operations. See, once the basic process is decided, the next step is to decide the principal process. Now, when we are saying principal process, it is the principal process is that process which follows the basic process, and the principal process can be machining, for example. Okay, that means what? First you cast it and then you machine it. Okay, or first you do forging and then a little bit of machining you may require to do. You see, like that. So these operations are basic operations and they are followed by the principal operations. Okay, like machining and other things also it can be. Okay, the principal process for one product can be basic process for other product. Okay, see, we are not saying only, see, the always basic process should be forging, casting only. Now, in this statement, what we have said is, see, the principal process for one product may be a basic process for some other product. Okay, if casting or forging is the basic process, after casting and forging, then you may need to do machining, and then machining becomes a principal process. But if for some other product, if the basic process is forming of a pig iron, if that is the basic process, then what follows from pig iron, like casting, this becomes the principal process. Okay, so when we are saying principal processes, examples of principal processes are given: extruding, rolling, drawing, machining, bending, forming, etc. Okay, see, these operations here that we are saying are referred as primary shaping operations. See, these are all giving shape. Extrusion gives shape, rolling gives shape, drawing gives shape, machining, bending, forming, all these, they give shape to the workpiece. So these are the principal processes. Okay, then the third one is the major operations. Major operations are the operations within the principal processes that may be classified in the importance of their sequence. You see, if the cutting is the principal process, then the major operations can be turning. Cutting means, like with machine tools, all these lathe machine, shaving machine, milling machine, broaching machine, these are all machine tools. So with those machine tools, you'll be cutting the work pieces. Okay, so when we are saying cutting, the major operations can be turning, shaping, milling, broaching, etc. These secondary shaping operations are generally metal removal operations and should be performed in the reverse order of accuracy required. You see, if more accuracy is needed, that operation will be done at the end, but less accuracy is needed, that will be done in the beginning. You see, mostly, okay, we'll read here itself. The sequence of secondary operations, that means the sequence means what comes first and what comes next. The sequence of secondary operations amongst themselves is dictated by logic. Logically, if we look at the things, we will find out instead of any specific rule. You see, example. Now you want to cut threading on a cylindrical workpiece. Now threading can be done after the turning operation on the lathe. So first you have to do turning and then only you can cut thread. Similarly, reaming is to be done. When will you do reaming? If you have drilled a hole, and after drilling the hole you can ream it. Okay. Another thing here they said is milling after grinding. First you have to mill it and then you have to grind it like that. This is according to logic. Now the first operation in the sequence of operations should be that operation in which largest layer of metal is removed. You see, where more metal is to be removed, you see, naturally, even if you think logically now, where you will remove bulk material, material removal will be done at the beginning, and towards the end, as go towards the end, you will be doing very little metal removal and more of finishing operations, surface finish, such things you will be doing. Okay. And why? Because by removing the bulk material, the largest layer of the metal, it relieves the workpiece of internal stresses. And if any internal defects are there, those things are revealed. That we will come to know about those things. And for removing the bulk material, largest layer of material, higher cutting forces can be used with more depth of cut. You see, when you take a finishing operation, the depth of cut will be very little. Otherwise, you won't get good surface finish. Okay, but when only bulk material is to be removed, at that time you can use high cutting forces and large depth of cut you can use. Okay, so these things are done at the beginning. Okay, towards the end, less depth of cut and lower cutting forces you should use. Okay, see, then after the bulk material is removed, major portion of the metal is removed, then roughing operations should be performed. And after roughing operations are performed, then surface finishing operations will be carried out. Okay, so the next one, now see, now we have started with basic process, then principal process, then major process. Now the next one, fourth one, is auxiliary process or auxiliary operations. Okay, now in the auxiliary, the name itself says it's an auxiliary. Auxiliary means in addition. That means these are not the major things. These are they are done in addition to the main operations. Auxiliary operations are those which are necessary to ensure continuity and completion of the major operations. They are necessary, though they are additional operations. They are necessary. They generally change the physical appearance or appearance of the workpiece, or physical characteristics or appearance of the workpiece. This is example of these auxiliary operations are given, like heat treatment, welding, shot peening, etc. You see, if you want if you want to give certain hardness to the surface of the material, so you may make it to pass through some heat treatment process. Okay, then otherwise, if you want to add some projection, we may use welding or something. If you want to induce some kind of compressive stresses on the surface, you may go for shot peening operation and other things. Okay, these are additional operations which are done after those initial operations are carried out. Okay, then we have the supporting operations. Now supporting operations, here also names suggest that this is not the main operation, it is only supporting operation. These operations are performed at the last stage to define the successful completion of the product. Okay, if this operation passes through this operation, that means that product is successfully manufactured or fabricated or machined, whatever. The inspection should be, say, inspection. This is one supporting operation. This actually examples are given here: inspection, quality control, packing, shipping, etc. These all come under supporting operations. Now inspection, when should you do? Inspection should be properly introduced in between the roughing operations. You see, once the bulk material is removed, then you go through roughing operations. When you're going through roughing operations, say, at that time inspection you can introduce. And and also before the material leaves for other departments, and before important operations are carried out, and after the last machining operation is carried out. At different stages you can insert inspection, and you can be checking the quality of the product. Okay, and after everything is done, you'll be packaging it. Okay, there are some of the, sometimes these are also some, some, if it is to travel long distances, and care, some of the products, more care should be taken. So packing also becomes an important thing, and then shipping also, how we are going to ship, and you know um, all those things, these big farm supporting operations. So that's how these five different operations we have seen now. See, basic, which are normally they are forging operation, casting operation. The principal operations can be extrusion, rolling, drawing, such operations. Okay, and then major operations can be machining operations like turning operation, shaping operation, milling operation, and auxiliary operations can be heat treatment, welding, and shot peening, and other things. And finally, the supporting operations are inspection and the quality control, and packaging and shipping, and such operations. Okay, now next, the information required to determine the operation sequence. Now what information as a process engineer you should have, so that you can you can determine the sequence of operations. Okay. See, now here is a list. The list, some 6 items are given. See, first you should have the list of the machines that are available in your machine shop. List of, not only list of machines available. Okay, and you see, here, the third point, you can see the capabilities of the machines also, you should know. Okay, so list of machines available, list of toolings that is available with you, then capabilities of the machines and the equipment that are already present with you in the machine shop. Then the plant layout. If in a machine shop, you should know where which machine is kept where, and how material will be traveling from one place to another place. Oh no, so because that will depend that will be influencing the sequence of operations, where the machines are placed, how they are placed. Okay, where, how the material will move, where are the conveyors. Okay, all those things matter. So plant layout also you should know, you should have information about it. Then machine loading chart you should know. Then standard time data, which with work measurement we have found out, these timings and other things you should know. So these are the things that you as a process engineer should, this is the information that you should have, this is required, so that you can determine the operation sequence. So after establishing the sequence of operations, it should be reviewed. Who will review it? Either your supervisor will review it, your manager, or whoever will be reviewing it, or you along with your colleagues, you can discuss about it. Because always, however confident we are that we have done well, still there is always a scope for improvement. So we should review it. Okay, then next topic that we are going to see today is the operation sheet. Now, what is an operation sheet? You see, the operation sheet shows everything about the operations, and indicates the operation description, their sequence, type of machines that you use, types of tools that you are going to use, and what are the setup times, what are the operation times. All these things your operation sheet will show. Now when we say operation sheet, how does it look? It is a table. It is like it is made in a tabular form. That means it is given as a table. Operation sheet is a table. Okay. The operation sheet varies from product to product and from one company to another company, but normally it will have the information that is listed here. See, it will have the name of the job, the number of the job, the size and material of the job, sizes of that job, and of what material it is made. Material means, like mild steel or cast iron or aluminum or whatever, the material. Then the description of operations and their sequence, that also it will have. That operation sheet will have the description of operations and their sequence. Normally the sequence is will be there always. That means which comes first, which comes next. Then the machines and tools used for performing the operations, all that also will be listed. Then cutting parameters like cutting speed, feed, depth of cut, these things also will be um, will be where it will contain all the our operation sheet will contain. Now see, a typical operation sheet may look like this. Okay, it may have part name, part number, the material, and the quantity. Okay, then it may have the operation number, the quantity, or the description. Is it quantity? Maybe something wrong here. Okay, it is the description of the operation description it should be. And machine and tools, machines used, tools used. uh, then what is this? Cutting speed, and then feed, then timings like setup time, operation time, and total time. You see, here now you may have number of operations 1 2 3 4 5 6 7 8 9 10, like that. And for each operation description, and then which machines will be used, and what will be the cutting speed, and what is the feed, and what are the timings, and all these things may be mentioned in the operation sheet. Okay, now let us talk about the importance of the operation sheet. You see, the operation sheet, the operation sheet, the following points will explain the operation sheet, the importance of the operation sheet. The operation sheet gives the information that is very vital, very important to the process engineer. Now, as a process engineer, your operation sheet will give the information, important information. It helps the supervisor. See, now the process engineer is a person who plans the process. Okay, and now we are talking about the supervisor. Supervisor is the person who will be above the worker. So it helps the supervisor also to know which operation is being performed on the job. Now, on the job anyway, see, a drawing will accompany along with the operation sheet. Okay, the operation sheet will tell the supervisor which operation is being performed. See, drawing alone will not show. Drawing will show this is how it should be looking finally when the machining is done. Okay, but the operation sheet will tell the supervisor which operations are going to be performed on the job. Then the third person involved here is the worker. It helps the worker. That means actually this is the person who will be handling the machine. Okay, the supervisor will be handling many workers, giving them job, motivating them, and supervising them, and taking a review of the work and all these things. Supervisor will be doing. Mostly workers only after some years may be promoted as supervisor, or like a diploma holder may be placed as a supervisor, diploma in engineering. Workers normally will be from ITA holders. Okay, you see, it helps the worker also to clearly understand the drawing, because drawing itself is not giving all the information. The operation sheet will give vital information. Then it also instructs the worker about the speed, feed, depth of cut, these process parameters which we call the speed, feed and depth of cut, which he is going to use for the operations. Okay, so it also gives the information about the time required for the operation. So you will know from the operation sheet how much time is allocated, and how much time it should be done. And this can help the process engineer to schedule the similar jobs. You see, if similar type of jobs are there, all can be scheduled together, uh, because the process engineer is planning the things. When he's planning, he can group those things, and he can schedule those things, similar jobs together. The information like the availability of the machines can also be obtained from the operation sheet. If any, if just some outsider also, if he sees an operation sheet, immediately will know, oh, they are having a milling machine. That's why in their operation sheet a milling machine is mentioned. They are having a surface grinding machine, that is mentioned. You see, just by looking at that, you'll be able to tell these machines are available in the company. And as the operation sheet is one of the activities in the process plan, you see, now process plan is the big topic under which we are studying all these things. Okay, the operation sheet is one of the activities of the process plan. It helps to get a systematic process plan. So this operation sheet making is necessary so that your plan will be more systematic. Okay, now let us see operation sheet to make a gear, how this operation sheet looks like, and how what all it contains. Okay, you see, the question here is prepare an operation sheet to manufacture a spur gear shown in the figure. See, here spur gear is shown in two views, and see, the pitch circle diameter is given, the central hole with the keyway and their dimensions, the blanks thickness, the gears thickness, and everything is mentioned here. The blank size is 27 by 65. So actually 65 is the diameter, and finally you have to turn it down to 60, because your gear is only of 60. That means 5 mm will be reduced, and the width is 27. The 20 instead of 27, you should machine it and bring it to 25. Okay, so this is what you have to do. Now how the sheet looks like, let us see. Now this is a sheet. You see, as we said, it is a table. This is an operation sheet for making that spar gear. Okay, now the operation numbers are given in the first column. The second column contains the description of operations, and the third one, which machines are used. Fourth one, the tools and fixtures which are used. You see, as we said before, these things may vary from company to company. Okay, so okay, this is a typical one which we are seeing here. The cutting speed in meters per minute can be mentioned here. The feed, millimeters per revolution, is can be mentioned in this column, and the depth of cut, here everything is put as dash, but the depth of cut also can be given. See, if he is a very highly skilled man, the worker, so it may not be necessary, but there is a place for it where you can give it. Okay, now let us see the operations. What you do, you cut the blank for a length of 27 millimeters. How you are cutting it? You are cutting in the cutting machines. Your hacksaw, power hacksaw, you may use for cutting it. So power hacksaw will be running at a speed of cutting speed of 20 meters per minute, and the feed you may use 0.025 millimeters per revolution. Okay. Now the second thing is, once this blank is cut, you have to clamp it on the lathe. However, where you are going to do it, which machine? Lathe machine, center lathe, and three-jaw chuck. That is the that is the so that is the tool holding device that you will use. Three-jaw chuck. Then the third is facing operation. You have to remove 1 mm. 1 mm stock you have to remove. Okay, now 27 will be reduced to one side. If you reduce it will be 26. Another side, if you reduce 1 mm, it will be 25. Okay, that is so much provision is there. 1 mm you can reduce. Okay, again, where facing operation, lathe only you will use, and high speed steel right-handed single point cutting tool is used, and 35 meters per minute cutting speed. This is mentioned in the process, in the operation sheet. Then you do the turning operation by reducing it to 60, because you were given a blank which was 65 diameter. Okay, now you turn it to 60. 60 means how much you should reduce? 5 mm. 5 mm means actually in lathe you will be reducing only 2.5, because you see, if your diameter, if you're reducing, actually it is not diameter, it is the radius that is getting reduced. So 1 mm you are cutting means on the one side 1 mm, the other side also 1 mm, 2 mm will be reduced. So 2.5 mm you have to reduce. Okay, you have to turn it. Okay, and again center lathe, and the speed, cutting speed is 40 meters per minute, and then chamfering is done. Center lathe chamfering tool 35. Okay, then the reverse the job, again do the facing. Yeah, here 1 mm is reduced, here 1 mm is reduced. Okay, now it is 20 instead of 27, it is 25. Okay, then again do the chamfering. Why? Where is the our job? See, here the chamfering is to be done, here chamfering. So now facing operation is this, from the center you may go towards the periphery like this. Depth of cut is 1 mm, so 1 mm this side you reduce, 1 mm this side you reduce. Okay, and after that you have to do chamfering. This chamfering tool you will use. Okay, at a 45 degree, um, and you have to drill a hole, center hole you have to drill. See here, initially as a blank it won't have, it will be a solid cylindrical rod. Okay, you have to do, how you will drill hole, that is also on lathe you can drill it with a center drill, and then initially you start with the central drill and then drill. You can fix this on the tail stock, and you can drill the hole. Okay, after the hole is drilled, clamp on shaper to cut the keyway. Now the keyway should be cut. Now for that, no, he has gone to shaper. Till now he was in the lathe machine only. Now he has gone to shaper, and keyway tool he used with 25 meters per minute cutting speed, and he machined it. Okay, he cut the keyway, and afterwards again he removed from the shaper, and he clamped on the milling machine on the universal dividing head. Okay, the universal milling machine. Okay, on its mandrel he has clamped it. And why? After cutting it, finally the major operation of cutting the teeth of this spar gear, that is done on the universal milling machine, and with the indexing head and other things, dividing head. Okay, cutting the required number of teeth, that is done with the help of a form milling cutter, and its cutting speed is given 40 meters per minute. You see, this is how an operation sheet looks like. Okay, now let us go to the next thing. This is another example of how operation sheet of a component on lathe looks like. Now this is the component to be machined. Okay, the diameter given is 50 here. Maybe the final diameter is 50 for a distance of 30 mm, and then it is turned down to 30 mm diameter for a length of 50, and then there is a taper of 3 degrees for a distance of 20. You see, these are the operations. So how your operation sheet looks. Now here is the operation sheet for that job on the lathe machine. Okay. Um, okay, you see, now we are not going to discuss about the fine minute details of this. You have to clamp the blank in the chuck. You have to do the facing operation. You have to turn it to 50 diameter for a length of 100, because uh, you see, 50 diameter, yeah, 50 diameter, the 100, because this is 30, this is 50, and this is 20, total is 100 okay. For 100 you have to turn 50. That means, everything will be this much diameter, like this, like this. It will be okay, cylindrical. That means 50 diameter cylindrical piece it will become. Then you have to turn the diameter to 30 for a length of 30 30, huh? It should be 50 now. Yeah, it should have been 50 here, because this distance is 50 See, this is 50 length. Okay, and afterwards, adjust the tailstock for taper turning operation. See, taper turning you have to do. So you have to here they are using the tailstock to do the taper turning. Okay, there are other ways of cutting the taper. Okay, taper turning of 3 degrees for 20 length on the center lathe, and the high-speed steel right-handed single point cutting tool is used. And finally, after everything is done, now first everything is made 50, and afterwards, for a distance of 50 30 diameter it is made, and then with the chamfering tool on the tailstock, they have done this one. First facing operation was done, is it not? Yeah, for facing operation is the first operation that we normally do on a lathe machine. First facing is done, then 50 it is turned, then 30 it is turned, and then on the tailstock taper turning, adjusting the tailstock with the chamfering tool, we cut the taper turning, and finally cutting off. For cutting off, what you use is the parting tool. So here, we will cut it, because this rod may be even longer. Okay, it may be. Okay, so this is how this operation sheet looks. And okay, there is another example here. Operation sheet to produce a hexagonal nut. Okay, and okay, I'm not going to discuss in detail this one. Okay, so these two topics that we wanted to discuss today, we have seen, and we'll stop here. Thank you.